Hey everybody, we are in chapter 8 and we are looking at similar polygons, and we have looked at the relationship between corresponding side lengths and corresponding angles and things like that with our similar polygons, and now we are going to look at the areas and our formula for how we find the area of similar polygons, because remember, area is the number of square units that would fit inside of a shape. And anytime that we are talking about area, we're talking about square meters, square miles, square feet, things like that. So if you look here at our formula that we're going to be using for finding the area of similar polygons, our polygons up here, one is smaller and one is bigger. The blue polygon is smaller, the red polygon is larger, which means the area of the red polygon will be more than the area of the blue polygon, obviously. However, let's figure out how we can find exactly what that area would be. So our formula that we're going to use is typed up in here, but I'm going to write it just slightly different. Okay, so how we would think about it is we would have the area of one polygon over the area of the other polygon. That looks a lot like what I already have typed. Okay, equals so on the other side, like I said, we are going to put some big parentheses here. And what we're going to have is a side length over a side length. And we are going to square them both. Okay? So, and of course, the area of whatever this triangle is would go with the side length of that triangle. The area of this triangle would go with the side length of that one. It doesn't have to be a triangle. It could be a square, a rectangle, a trapezoid, whatever. So here's our formula that we're going to be using. So let's go ahead and look at a couple of examples. Okay, so here we have two similar triangles, and we want to find the area of the smaller triangle. Well, it tells us the area of the bigger triangle is 36 centimeters squared. What we're trying to find is the area of that smaller triangle. Okay, so, and it also tells us here's a side length of the big triangle and the side length of the small triangle. So when we set up our proportion on the one side, remember, it's everything in this chapter, it seems like, is proportions. On the one side is area over area. So I'm going to go area of the big triangle, 36. And we don't know what the area of the small triangle is, so I'm going to call that x. Then on the other side, I'm going to go side length over side length. So that means in my big parentheses here, if I have the big triangle on top here, that means the side length of the big triangle has to go on top, and the side length of the small triangle goes on the bottom, and we have to square them. Okay, so I know that we can say 10 divided by 5 is 2, but we are going to go ahead and go through the process with the exponents to make sure that we know how to do that. So I'm going to leave this 36 over x on this side, and anytime that we have a squared on the outside, that squared has to be applied to everything on the inside. So we need to square 10. So in the numerator, we are going to get 10 squared, which is 100. And in the denominator, we are going to get 5 squared, which is 25. Now, once we have our proportion, there's no squares in there, anything like that, we are going to go ahead and do the butterfly method. So we would say 100x equals 36 times 25. So let's check what's 36 times 25 is 900. We're going to divide both sides by 100, and we get that the area of our small triangle is 9, our units here are centimeters squared. Okay, and we always want to check to make sure that makes sense. So if the bigger one is 36, obviously the smaller one needs to have a smaller area, and it's going to be 9 centimeters. Let's go ahead and look at another example. Okay, here we have rectangles, and the areas and the rectangles are similar. So what we need to do, again, we're going to set up that formula, area over area. We know what the area of the little guy is. What we don't know is the area of the big one, okay? So I am going to say the area over area, I'm going to have 84, that's the area of the small triangle, over, well, I don't know what the area of the bigger triangle is, okay? And then I'm going to go side length over side length squared. So my side length, I have the smaller triangle, or rectangle on top here, so I'm going to have 7 over 21. Again, anytime we have that squared on the outside, we need to make sure that we are distributing that squared to everything on the inside. So I'm going to have, let's see here, 84 over x. We're not going to do anything with that just yet. 7 squared is 49. 21 squared, let's check here, 21 squared is 441. So calculators are going to be helpful here. And now we're going to go ahead and butterfly and cross multiply. 49 times x is 49x, and 441 times 84 is 37,044. Go ahead and divide that 49 on both sides. And we should get 756. And what are our units? Well, let's go back and see. Meters, so anytime we're in area, it would be meters squared. Okay, let's go ahead and look at just one more. Here we have a parallelogram, okay, and it tells us in words here, doesn't it say it right below there, the area of the smaller parallelogram is 24 units. 24 square units, and we don't know the area of the larger. Okay, but we do need to make sure that we are using corresponding sides, so we want to make sure that we are using, if I'm using 3 over here, I'm using 4.5, and since we don't have anything that corresponds to 4, we are not even going to use 4. That's just extra information, so we are not necessarily going to use every piece of information that's given to us. So we have area over area, so I'm going to have 24, because that's the area of the smaller one, over x, that's area over area, equals side length, 3 over its corresponding side length, which is 4.5, and I need to square both parts of that. Okay, so I'm going to leave that 24 over x the same, and like we've been saying, that squared needs to apply to both the 3 and the 4.5. And 3 squared is 9, we know that one. 4.5 squared is 20.25. And again, once we get these numbers here how we want them, we can butterfly method and cross multiply. So I get 9x equals 20.25 times 24 is 486. And if I divide 9 on both sides, I get that x equals 54. And let's look up here, what are my units? We are in centimeters, so we would call that centimeters squared. Okay, once we are finished with the notes, you will find that there is a Big Ideas assignment online that you need to complete, please.